Robin Landry, and I worked on researching the motors for this project.
Hi, I'm Tanya Keenan, and I worked on the schematic diagrams for this project.
Hi, my name is Caroline Ty, and I worked on the wheel design and the construction for this project. We all collectively worked on the chassis.
The goal of this project was to create a robot that would climb to the second floor of the stairs by the STEM classroom. This would require being able to turn and climb up 26 steps. It was inspired from a student's suggestion to build an all-terrain robot.
To achieve this goal, we took many steps to understand the stairs and the mechanics of stair climbing. We started by measuring the height and depth. We also noted any specific details of this set of stairs that would affect the build of our robot.
In class, we also learned about stability, center of mass, and gravity to help with the design of our chassis. We learned about circuitry and electrodynamics, learning about different laws like Ampere's law and Ohm's law.
The stair climbing robots our STEM class built are quite small, but if we were to upgrade them to a larger scale, it may be very useful for people in wheelchairs or elderly people who have difficulties walking up the stairs.
Our final project has 4 main parts: the chassis, wheels, motor, and a power supply. The chassis is made of Vex robot parts. The wheels are made of half-inch thick foam board. There are 4 motors rated at 12 volts with 30 RPM, and the power supply was a regulated DC power supply that could reach 50 volts.
We researched many different styles of chassis, but settled on a basic rectangle because we thought it would be the quickest to build and quite light for our motor capacity. We went for a hook-shaped tri-wheel rather than a standard round wheel because we thought it would hook onto the edge of the stairs and be more effective in climbing.
We started with a thicker, more stable chassis built with Vex Robotics material. This material is very light and has pre-made holes in it, so it was easy to make our robot look how we wanted it to. Because the motors were quite heavy, we decided to use half-inch thick foam for our robot wheels. This was thick enough to hold up our robot but did not add a lot of weight to the total mass of our project.
After many tests, we lightened our chassis by rebuilding it with a thinner but more flexible frame. We added reinforcements along the lengths of our front wheels because we found that these wheels were under the most stress. We also added anti-slip tape along the edge of each wheel because we found that the foam was slipping off the stairs and that this way they could grip better. After all of these alterations, our robot was able to climb a couple of stairs.
Although the motto of STEM is fail fast, fail often, it almost felt like this project was just a lot of failing. We experienced one difficulty after the other, but were able to overcome them for the most part. For one, we began by using a very heavy 12-volt battery. However, once we completed a schematic diagram and researched the motors more, we were able to see that our motors could actually handle a higher voltage, in turn causing them to have more torque. That's when we switched to our other power supply, which worked a lot better.
We also struggle with our motors spinning within the hubs. Taking our wheels on and off to make adjustments caused our motor hubs to become loose. What we ended up doing was collaborating with another group and using their wheels with our chassis. The other group had a very similar design to ours, however purchased their motor hubs, in turn avoiding the initial problem that we had. The switch in motor hubs and wheels was a success for our group, and our robot climbed the first set of stairs. For most groups, this project was challenging. Creating a robot that climbs the stairs is a difficult task, but poor organization and planning can add to this difficulty. I think that our biggest takeaway from this project was the importance of planning in a project and group organization. At the beginning of the project, we made a group planning document where we wrote important deadlines and the goals that we had set for ourselves. Throughout the project, we also began having team meetings at the beginning of each day to organize ourselves and plan out what we were going to do that class.